Because if I go to the one on the third, then I'll have my 4 turns. But
all right, do you need another minute? Are you ready? Ready? Okay, let's go over it. All right. So we have SF2. So if we draw this out, sulfur has 6 valence electrons. Fluorine has 7, but there's 2 of them. So we have 14 plus 6 valence electrons that we need to show in the structure. So this gives us 20 electrons. So I'm going to pick sulfur to go in the middle. I'm going to connect to fluorine. So I've shown 2 4 electrons. I have 16 left to show. I'm going to start by filling in the outer atoms. So that is 6 plus 6 is 12. I have 4 electrons left to show. So I'm going to put those 4 electrons on sulfur. Okay, and this is why this is a tricky question. We need to figure out, okay, so how many electron groups are around the central sulfur atom? What's that? Huh? There's 4. So this one's the number 4. And then this is the tricky part. What phrase best describes the arrangement of these electron groups? So this is talking about the electron geometry. So you include all 4 groups. So this is going to be, we have 4 electron groups. The arrangement of the electron groups is going to be tetrahedral. Okay, questions on that? That was our most type of question. So just watch out, is it asking about the electron groups, then you're going to include the lone pairs, you're going to include the bonds. If it's talking about the shape of this molecule, you ignore the lone pairs, and that would be bent. But this one is, the electron geometry is tetrahedral. Okay, questions on that? Okay. Let's look really quick at our schedule. Again, chapter 5 is a little bit harder. We have some math and we have some kind of new concepts. So this, I would recommend as we learn the topic, try to get it done in ALEC so you're not getting behind. There's a lot in this chapter. We're going to take 4 class periods to get through all the material in chapter 5. Okay, so we're on Monday. We'll talk about chapter 5 Wednesday, Friday, and then Tuesday. Then we'll have lab 6. We'll review chapter 5. Then we'll have a break, which I know is kind of annoying, but at the same time, then you have all of Thanksgiving break to review for the test. Okay. So just be prepared. Chapter 5, I think it's harder. So make sure that you are paying attention. Make sure that if you have questions, please ask me early. We'll get it figured out. Don't wait till the last day to do the Alex. Okay, Alex is going to be due on the 20th. But make sure that you're making progress through Alex as we go. Okay, questions about that? The other kind of weird thing about this is that we're going to jump to lab 6. Now our labs are not going in order. So the next pre-lab you need to do is lab 6. Then we'll jump to lab 11, then we'll jump back to lab 8. So just kind of watch the schedule for that. Okay, questions about our schedule before we jump in to our notes? Okay. All right, chapter 5 is about chemical reactions. So this is kind of exciting. We're starting to talk about chemical reactions. So these are our objectives. We're going to talk about writing chemical equations, balancing chemical equations. We're going to talk about calculating a molar mass. We're going to talk about this number. We're just going to talk about what it is today, and then we'll use it next time. This Avogadro's number. And then we're going to talk about this. This is an Alex topic that's really confusing, and that one's really tricky, so we'll start talking about it today. We're going to try to calculate the moles, the number of moles. It'll give you a number of things, and you have to figure out the number of moles. Okay. So this is what we're going to try to cover today. So when I talk about a chemical reaction, what does that mean? So maybe think back to lab 4. How did you know there was a chemical change or a composition change? How do we know there's a chemical reaction?
It was different after we did the thing to it. Like they were actually different.
Good. So we did a test, and then we changed we did like some tests. We changed the compound, and then we did the same test. So if those tests didn't match up, then that was a chemical change. Good. Okay, good. So in a chemical reaction, we are forming new bonds. So here's an example of a chemical reaction where we start with oxygen, and this is methane. And then we end up with new bonds. So the carbon-hydrogen bond broke, the oxygen bond broke, and then we have new bonds. Now we have a hydrogen-oxygen bond and a carbon-oxygen bond. So in a chemical reaction, we are looking for new bonds forming. And new bonds, so our bonds breaking and then forming new bonds. Okay, the other thing that we look for is we have these different words. We have the reactants and the products. So when it talks about when we're talking about the reactants, that's what we're starting with. Those are the starting compounds. And then we have some kind of chemical reaction, and we use an arrow to show that we have a chemical reaction. And then the products is the thing that we end up with. Whatever compounds we end up with at the end are our products. Okay. All right. We also need to know about the law of conservation of mass. I think this is probably a review from your previous science classes. Do you guys know what this is? What is the conservation of mass or conservation of matter? Do you know this one?
Stay the same if its shape changes, like its form.
What stays the same?
Well, the mass stays the same if it
Okay.
changes from solid to liquid or gas.
Good. Okay, so mass stays the same. Good. So mass. Okay, I'm gonna add the mass stays the same after before. Let's put like before and after a chemical reaction. Okay, good. So whatever mass I had when I started with, I have to end up with that at the end. There was a topic kind of like this in chapter 1 on the chapter 1 test, and we had to count up the atoms. The other thing that you can do is we have to have the same number of atoms at the beginning as at the end. Okay, so let's do an example. So if I have 12 hydrogens and 6 carbons, then after the chemical reaction, I better still have 12 hydrogens and 6 carbons, okay? So that's another way to put our law of conservation of mass. However many atoms of each different element I have to start with, I have to have those at the end, okay, for a regular chemical reaction. Okay. Oops. Okay, so here, this goes along with the law of conservation of mass. So the balanced chemical equation must show the same number of each type of atom on the reactants and the product side, and that's what we just said. Atoms cannot be created or destroyed in a chemical reaction. We can't get rid of carbons, okay, unless that's a nuclear reaction. We're not talking about nuclear reactions, we're talking about just regular chemical reactions, okay. So if we have this chemical reaction, I think this is a good example. We can count up how many carbons on this side. We have 1. If we count up the carbons over here, we have 1. We have 4 hydrogens over here. We have 2 times 2. We have 4 hydrogens over here. We have 4 oxygens and 4 oxygens. So this is a balanced chemical equation, and also this chemical equation shows the law of conservation of mass. And that's why we balance chemical equations, which is one of the things we have to do in Alex. Okay, questions? We're all right? Are we okay? I can't tell. Are we okay? Okay. All right. So here are some more symbols. This is our phase symbol. So let's guess what these are. What would so the coefficient? This is a coefficient. This just tells us how many oxygen molecules we have. 2 O2 molecules. We have 2 H2O molecules. We have 2 water molecules here. What is the phase symbol? So this is telling us the phase of methane. What is solid? This is solid. What is S solid? Very good. I just read that one. How about this one? This is L. What does L stand for, do you think? Yeah. Liquid. Okay, G would be what? Good. And then this one is new. Does anyone know what AQ means? Good. And do you know that too? Aqueous. Good. Can either of you tell us what does aqueous mean?
Solid dissolved.
Good. A solid dissolved in liquid, specifically dissolved in water. So if we have this phase, that just is a solid dissolved in water. Okay, so if I see AQ, that means the thing is dissolved in water. Okay, and then sometimes we see this triangle. This triangle means heat. We talked about sometimes the triangle means change. Did we talk about that here? Okay, never mind. This triangle means heat or energy. Okay, so usually we heat it up with a Bunsen burner. Okay, I don't know why, but it looks like a little fire to me. And I don't know why it's a triangle. That's what sticks with me, is that, oh, the little triangle means that we put our reaction in a flame. Okay. So you will see these symbols in Alex. I just want you to know what they are. Okay, questions on that? Are you doing okay so far? All right, very good. Okay, so let's go ahead and try this. There's going to be an Alex topic where you have to count up the elements. So if we're counting oxygens on this side, how many oxygens? Good, we have 4 oxygens, okay? How many oxygens on this side? So we've got 2 here. Then we also have an oxygen over here. And this coefficient is telling me I have 2 waters. So yep, I have 2 oxygens, so that's also 4. So 2 from here, 2 from here, that gives me 4. Okay. So when I go on to chemical equation, I usually like to make a list of, so I've got oxygen, I've got 4, I got 4. Okay, so the oxygens are gone for this equation. Okay. Questions on that? That's going to be one of the oxygen pictures. It'll ask you like how many are on this side. Okay. All right, very good. How many oxygens on the reactant side? So which side is the reactant side? Left or right? Left, good. So reactant side over here. How many oxygens are over here? So we got 3 times 2 is 6, plus 1 is 7. Good. And then how about on the product side? So this would be our product side. Do we have the same? Also 7. Good. So we have 2 times 2 is 4 oxygens here. 3 times 1 is 3. So I've got 4 plus 3 oxygens is 7 oxygens. Okay. All right. Do you want to practice this or do you want to work on this on Alex? What do you think? You think you understand that? Should we skip this? Okay. All right. Let's see if this reaction. I haven't done all of the Alex topics, so let me see if I can pull this up. In Alex, there's going to be a topic where you have to watch a little, like, sort of slideshow thing. Where is mine? And then you have to decide, did a reaction occur? So, oops, sorry, my sense. This is what you need to look for when you are doing this topic. So, you need to make sure that there is a collision. If there is not a collision, then you can't have a chemical reaction. You also need to look at the reactants and the products. And you need to see what did you start with? What elements did you start with? And then after the collision, what happens? What is the products? So just understanding this topic is kind of weird, but I don't think it's that hard of a topic. It's just kind of a weird one. So let me just see if I can find it. Okay, it's called writing a chemical reaction from a molecular movie. So if you have this topic ready, you can do it with us. It's in chapter 5, chemical reactions, writing a chemical equation from a molecular. So if it's locked for you, you just have to do topics before you can get to that one. Does that make sense? Okay. All right, so once you get to that topic, what you're going to do is you're going to drag the movie, okay? And you have to look for a collision. If there are no collisions, you cannot have a chemical reaction. Okay, so this one, there is not a chemical reaction. So then you just end. So that's a nice one. Does that make sense? So none of the molecules hit each other. Nothing happened. No reaction. Or like maybe they bumped here, but okay, there's a collision right here. Watch that. Collision. But nothing happened. They just bumped each other. Okay, nothing happened. Okay. So no reaction. Okay, let's find another one. So how about this one? Let's watch. Oh, did anything happen?
Yeah.
Alright.
Right one.
In the middle? Oh yeah, okay. So here, watch right there. I didn't see it for a minute. Okay, so there was a collision, and now we have something new. So we can write a chemical equation for this. Okay. What phase does this look like?
Gas.
Gas, good. So this is going to be, we're going to have to label all of these as gas phase. Okay, so we need to figure out, what do we start with? What are our reactants? Let's see if I can write on the board. Let's do it here. Okay, we have this thing. We have 3 of those red things. That's 3 oxygens. This is called ozone. I don't think you need to know that. I'm just telling you that. O3. And then we're going to add, What is this thing? Good, we have nitrogen from our key, that's a blue one with 2 oxygens. Okay, and then what do we end up with? What is our product? So that's what we start with before the collision, and then they collide. So what happens after? What do we end up with after the collision? O2 and NO3. Okay, so we have the baseline of the reaction, but we're missing a lot of pieces. So one of the pieces, as we have to write the phase, these are all gas phase. So we need to label each one of these gas phase. Okay, the other thing we're missing is we need to balance this. And I don't think we've talked about that yet. So let's go ahead, let's just try it. We'll call this our reactant side and this our product side. We have 2 elements. We have oxygen and we have nitrogen. So how many oxygens are here? 3, and 2 here, 5. And how many nitrogens? Just 1, okay? So we just need to check on this side. Do we have, how many nitrogens, I guess, I'm just going to flip. 1, and how many oxygens? 5. So this one worked out. We don't need any coefficient. So when I type this in here, I'm going to say, yes, this one has a chemical reaction, and then my balanced chemical reaction would be, it doesn't matter the order, so I'm just going to put O subscript 3 plus, 3 over plus, and I have to put the phase, parentheses gas, plus this is NO2 is the next one. Gas, this is also gas. I think they might all be gases on this problem. So just kind of watch out for that. O2 plus NO, oops, oh my gosh, my fingers are not on my ones. 3, I forgot my gas, so we should put gas. Okay, and then let's just check. Oh, and I can't use the board because it's right. Okay, does that make sense how to do that? Okay, so once that topic gets open, it's not too bad. It's just weird to kind of set it up, okay? And figure out, oh, was that a collision? Did something new happen? Okay, we'll leave Alex over for a minute. All right, and order of the elements in the chemical reaction matters. So the order of the compounds doesn't matter. I could have put NO2 first, that doesn't matter. But N has to come before oxygen in my compound, just like our rules before. Okay. All right, let's clear this. Okay. Questions on that movie? Question? All right. Oops, where is the mouse? Okay, we need to balance the chemical equation because we need to have the conservation of mass. We have to have the same number of carbons that we start with as that we end with. But we also need to know the ratio between the compounds. So if we're trying to make aspirin, and we're trying to add salicylic acid and acetic acid, we need to know the ratio that we're going to add them to figure out how much we need to add to get aspirin, okay? So for this compound, this is balanced. I just need one salicylic acid molecule for every 1 acetic acid. So this is a 1-to-1 ratio. But part of balancing is we need to figure that out. Is that 1-to-1? Is it 2-to-1? Okay. And we also talked about the conservation of mass. If you're getting stuck on this, I've linked a PhET lab. There's a PhET conservation of balancing chemical equations lab. And that kind of walks you through, like, it has little pictures, so that's kind of a good, if this is really confusing to you, you can look at that lab. So I have that linked in here, but we're not going to take time to do that. We're just going to jump into how to balance an equation. So we're going to write the reactants on the left, the products go on the right. We're going to check is it balanced. So we'll list out what elements are on the reactant side, which elements are on the product side. They should be the same. And then we need to count them up. Okay, and then we cannot change the subscript. So if I need another oxygen, I can't just add a subscript. I have to add a coefficient. I have to say, no, I can't put a 2 at the end. I need to put a 2 in the front. I need 2 molecules. Okay, we can't change the molecule. So the way to start this is you figure out the compound that has the most complicated formula. So if it has 4 elements, you're going to want to pick that one and put a coefficient of 1 in the front of that. And then you're going to balance the elements based on your most complicated compound. Okay. And then you're going to check to make sure, once you have all of the balanced numbers, you make sure that you have the same number of atoms that you start with at the end of your reaction. Then you're going to see if you can simplify the coefficients. We need the simplest ratio. So if all of my coefficients have a 4 in the front, I need to simplify that so that they're divided by 4. And then if we use the fraction, this is sometimes we'll need a fraction, and that it just is a little bit when we use a fraction, it's a kind of harder problem. If we need a fraction, then we're going to multiply by the denominator of the fraction through the whole equation. So I think this makes more sense if we do some examples. So let's go ahead and go through. So for this one, I'm going to give you an example, and then I'll give you some that you can practice. So this is what I would do. I would write down, I have aluminum, I have oxygen, I have a hydrogen, and then let's see, I have sulfur. Okay, so I better end up with aluminum, oxygen, hydrogen, and sulfur on my product side. Okay, so then I'm going to count up how many of each I have. I have 1 aluminum on this side. I have 3 oxygens here, 4 oxygens from over there. That's 7 oxygens. I have 3 hydrogens plus 2. That's 5 hydrogens. And then I have 1 sulfur on this side. Okay, so I'm just counting. I'm going to count on this side too. I have 2 aluminums, 12 plus 1. Is that right? 12. Do you agree with that? So 13 thanks. And just 2 oxygens over here, or hydrogens, and then 3 sulfurs. Okay. So looking at these, yeah, none of them match up, so we're gonna have to move some coefficients around. Okay. So looking at this one, I'm gonna pick this one. This one has 3 different elements. This one has 3 different elements. This one has 3 different elements. But this one has the most elements. Okay, I've got 12 oxygens, 3 sulfurs, 2 aluminums. That's a lot of atoms. I'm going to put a coefficient of 1 here. That's where I'm going to start. Okay, I'm going to lock that one into 1. Okay, and this just takes practice to figure out which one is going to be the most complicated. And if you pick the wrong one, you can still puzzle it out. Okay. So I'm going to say that one's 1. Then I'm going to try to match this side to this side. Okay. So I have 2 aluminums here. So how can I make this have 2 aluminums? I'm going to put a 2 in the front. Good. It's kind of on the edge. That's a very nice 2. So now I'm going to change my numbers. I've got 2 aluminums. That one matches now. And then I have 2 times 3 oxygens is 6 oxygens here. Plus 4 is 10. Is that right? Are we okay so far? Okay, I get confused when I'm setting up here, so let me know if I mess something up. 2 times 3 hydrogens is 6 hydrogens, but there's 2 here, so now I've got 8 hydrogens. We're all right so far still. And then I have 1 sulfur. Okay, so I'm gonna change this one now to match because I want 3 sulfurs. Oh, so how did I do that? I changed this number 3. So now I have 3 sulfurs. I have 6 plus 6 hydrogens is 12 hydrogens. Where are we now? How many oxygens? That changed my oxygens. Now I have 12 plus 6 is that 18? Okay. So now these two are matching, but this is not matching. So what can we do over here to get, we need 18. So right now we have oxygen, we've got 12 oxygens here. How can I make this have I need 6 more, right? To get to 18. So I'm gonna put a 6 here. So I got 6 oxygens, 12 oxygens, now I have 18 oxygens. But that updated my hydrogens too. Now I have 12 hydrogens here. And that's all, 12 hydrogens. Oh, you guys just haven't moved. I have these motion sensors. There we go. Okay, so now it's balanced. The other thing I need to check for is I need to make sure that this is the simplest ratio. I can't divide out the same number from all of them. So this is simplified. Okay, if they were all divisible by 2, I would divide out by 2. Or divisible by 3. Okay? So this is something that takes practice to be able to see where to start, and then listing out the elements, counting the elements, and then figuring out what numbers go in the front. Like, this is not something that you just know, okay? Some people might be able to do that really quick, but this is something that, for me, I have to really practice this and write it out and show my work and practice a lot of problems to be able to do this, okay? All right, questions on that? Does that kind of make sense, the process? Okay. All right, do you want to try this one? Okay, go ahead and try this one. Yeah.
So the H and would it be written C and H?
Yes, but this one is kind of like, this one is an exception. This one, it has to do with how the molecule is bonded. So hydrogen is bonded to carbon, is bonded to nitrogen. The other way you can think of this is more as an inorganic compound where you have the metal, which is hydrogen, and the polyatomic ion, CN. So that's another way you can think about it. But yeah, I agree with you. This is an exception in chemistry. I can do that. Are you guys trying to class? I think the bell hour is 2 o'clock. Yeah. I think the target was 8. Go to your yeah. It's third period. All right, how are we doing? You ready to go over it together? Okay. Okay, this one is tricky. What did you guys pick as the element that we should start with a 1? Or the compound. Any ideas? So we're looking for the most complicated compound. So the one with either the most different elements or the most elements. Good. So I'm gonna put a 1 here. Good. Okay. And then also let's write out to start with. We have 1 nitrogen. We have 7 hydrogens, 7 oxygens. We've got 2 of those right now, and we have 1 carbon. So then over here, we have 1 nitrogen. It's helpful to write them so they match, so that if you can keep it organized, it helps a little bit. We've got 3 hydrogens over here, and we have 1 oxygen, and we have 1 carbon. Okay, so some of these match. Let's go ahead and try to balance the hydrogens first. So what if we put a 2 in front of this? 3. Let's put a 3. Then I'll have 6 hydrogens, 7 hydrogens. So I'll have 6 from here and 1 here That's 7. Okay, so that's balanced. Now that also updated the number of oxygens we have. Now we have 3 oxygens on this side. So then let's go over here. This one we have 2 oxygens. So I'm going to use a fraction. I'm going to say I want 3 oxygens, but there's 2 here. So this is 3 halves of an oxygen. So if I do 3 halves times 2, this is just like a trick that we learned. If we have 3 halves times 2, now I have 3 oxygens. Does that make sense? So I just put in the number I want and divide it by whatever number is here. Okay, that's a kind of tricky. Okay, now my oxygens are balanced. Hydrogens are balanced, oxygens are balanced, nitrogens and carbons are balanced. So everything is balanced now. But in the final answer, we cannot have a fraction. So how do we get rid of the fraction? We're going to multiply by the denominator. So if I multiply everything by a 2, so this is going to be multiplied by 2, this is going to be multiplied by 2, times by 2, times by 2, times by 2. And then my coefficient can be updated. Let me do this in a different color. Can you guys see red? Okay. Okay. So 2 times 1 will be 2. 2 times 3 halves, that will just cancel the 2 and I'll get 3 in front of that. 2 times this will have a 2. 2 times this 1 will be 2. 2 times 3 will be 6. Then let's go back through and check our numbers. We've got 2 nitrogens now, that's balanced. How many hydrogens? I've got 6 plus 8 is, thank you, 14. And oxygens, I've got 3 times 2 is 6. Carbon, I have 2. And then we jump over, now we have 2 nitrogens. We have 6 hydrogens times 2, that's 12, plus 2 is 14 hydrogens here. Oxygen, we've got 6 oxygens here. And we have 2 carbons. So now this is balanced, okay, with our final coefficients. So that's, if it's really not working out, you have like, usually this happens with oxygen, if you have oxygen, or sometimes with water. If you have one of something, it's easy to balance the thing with only one element last. So balance oxygen last, balance like metals last, okay? All right. Do you want to take more time in class? We have about 30 minutes left. Do you want to take more time to practice these with like here, or do you want to practice these in Alex on your own? What do you want to do?
Can we do one more?
Sure. Yep. Let's do one more. Okay. So maybe do you want to try the top one? Okay. Try the top one. Oh, this is our last slide, so we'll have to do the top one and then practice in Alex. You ready? All right, do you want another minute? Are you ready to go over it? What do you want to do? Okay. All right, so for this one, we just have 3 elements. Let's change back to our black pen. There we go. So we've got carbon, hydrogen, and oxygen. The nice thing about this one is you know which one is most complicated. It's really easy to pick, right? The first thing is really complicated, okay? We're going to use a coefficient of 1 in front of this because this is a really kind of ugly formula. So this is written because the structure follows this pattern. And we'll talk more about this in chapter 11 through 13. But you will probably see one of these on Alex or in your homework or on the test. So that's why this one's here. So how many carbons did you end up finding? 9? Okay, good, 9. How many hydrogens?
20.
Okay. How many oxygens on this side right now?
2.
Good. Okay, how about over here? We just got 1 carbon, 2 hydrogens, and 3 oxygens. Okay, so I'm going to start with carbon. I need 9 on this side, so I'm just going to put a 9. I remember I put a coefficient over here of 1. So now I have 9 carbons, and my oxygen number also updated. So 19. So I've got 18 here, plus 1 is 19. The other thing I want to balance next is the hydrogen in the water. So I only have 2, I need 20. How do I get 20 out of that? Good, times by 10, perfect. So then I have 20 now, so carbon and hydrogen are balanced. And I left oxygen last. It's easier to balance the thing that doesn't have any other elements. So this is only oxygen. It's easier to balance that last, okay? So, I also have to update, how many oxygens do I have here? 28, I think, because we've got 9 times 2 is 18, plus 10 is 28. So then I need a coefficient here times 2 that gives me 28. Good, so I'm going to put a 14 there. Now I've got 28, so now it's balanced. The other thing that I do here is I need to check. Just always check, can I divide a number out of each of these? No, this is simplified. We're good. Okay. All right, questions on that? Okay, we have 10, 20 minutes. Yeah, we've got 20 minutes of class left. I would pull out chapter 5 Alex and kind of work through that. You could also work on chapter 4 lab if you haven't finished that one. You could join on it. That one's going to be due next Wednesday, so make sure you get lab or in by next Wednesday. But again, make sure you're working through these Alex topics. Balancing is something that we're going to use through the rest of the year, so make sure you understand that. And all of chapter 5 is related to balancing chemical equations, so make sure you can do that.